Welcome my dear children, I am Sir Sonal, your physics teacher. Good morning students, I hope you all are fine. Okay. These days we are discussing our first chapter, physical quantities and measurement. Today we are going to discuss an important topic from this chapter, determination of density of regular solids. Determination of density of regular solids. All those who have the book, please take out your book, others please stay on video. Okay students, here is our topic, determination of density of regular solids. Last class means last section we have discussed that how to find out the density D by using the formula density D is equal to m upon V. Here is the formula. Density D is equal to m upon volume. To find the density of a regular solid by using this formula, we have to follow some important points. First one, that is using a beam balance, we have to measure the mass of the given solid. By using a beam balance, we have to find out the mass m of the given solid. Then we need the volume. How to find out this volume? By using the meter ruler, first of all, we have to find out the length, breadth and height of the given solid. If you are getting length, breadth, height, we have the formula to find out the volume. That is V is equal to length into breadth into height. Okay students, so we got now m by beam balance, V by the formula V is equal to length into breadth into height. Then use the main formula D is equal to m by V. Then surely we will get the density of the regular solid. Determination of an irregular solid. Now we are going to discuss about the point determination of density of an irregular solid. To determine the density of an irregular solid such as a coin or a piece of stone, we have to find out the measurement of its mass and volume. Okay, for this we proceed as follows. First of all, measure the mass of the given solid by using a beam balance. To find out m means the weight, the mass, that is very easy to find out the mass by the beam balance. Then to measure the volume of the liquid, we use displacement method. We have to use displacement method to find out the volume of the liquid. For this, what we have to do? Take a measuring cylinder. Fill it partly with water. First of all, take a measuring cylinder and fill partly with the water. First of all, what we have to do is note the level of the water. Let it V1 ml. Okay, first of all, we have to note out the level of the water. That should be written as V1 ml. Then now tie the given solid with a thread like this. It is given in the diagram. Okay, it is given in the diagram, you just observe. Okay, the activity we are going to do to find out the volume like this. Okay, you just observe the diagram. Okay, next what we have to do, now tie the given solid with a thread and gently immerse the solid in water contained in the measuring cylinder. Then take care that no water splashes out. Take care that no water splashes out. Note the level of the water again. Let it be V2. The initial level it was V1, don't forget. Now second one, the final one, that is V2. Okay, students. Now next point, find the difference V2 minus V1. Find the difference V2 minus V1, that will be volume V. That will be volume V. Find out the final level minus and initial level. Minus final level and initial level. Then we will get the particular value V. Then calculate the density of the solid by using the following relation. We know the relation, that is density is equal to mass upon volume, that is equal to m upon v gram per centimeter cube. First of all, we found that the mass by beam balance, and we found that the volume by displacement method. Finally, we had to use the equation. Density is equal to mass upon volume, that is m by v. The unit it is, density is here, it is gram per centimeter cube. Now we are going to discuss about determination of density of a liquid. Determination of a density of a liquid. Then how to find out it? To determine the density of a liquid, follow the procedure given below. Here also we have to take out a beaker. Then measure the mass of the empty beaker by using, it is very simple to find out the mass of the empty beaker by using the common balance. Here we use the apparatus common balance. Let the mass be m1 gram. Let the mass be m1 gram. Then now take a measuring cylinder and pour milk into it to a certain level, say suppose that 50 ml. Thus volume of milk V is equal to 50 centimeter cube. Second point, what we have to do, now take a measuring cylinder and pour milk into it to a certain level, say 50 ml. Just 50 ml milk you pour in a cylinder. That is the volume of the milk. V is equal to 50 centimeter cube. Why? We know that 1 ml is equal to 1 centimeter cube. That's why V is equal to 50 centimeter cube. Then what to do? Transfer the milk into the empty beaker. Transfer the milk into the empty beaker. Then measure its mass again. Let its mass be m2 gram. Let its mass be m2 gram. The difference between m2 and m1 will give the mass m of the milk. M already we have calculated here by using the common balance first of all, clear. Then now we got the m2 final mass after pouring the milk. Then now suppose that the m is equal to 51.5 gram. Now we are getting the mass 51.5 gram. Calculate the density of milk using the following relation. Density is equal to, we know that the equation that is density is equal to mass upon volume m upon v gram per centimeter cube. Now we got both values. M is equal to 51.5 gram, V is equal to 50 centimeter cube. Then by calculating these both, we are getting the final answer 1.03 gram per centimeter cube. So we got the, basically we got the density here. So different substances have different densities. the table given here, you just observe the different densities of some common substances. So, it is given, you just observe it. In solid substances, coke 0.25 is the in gram per centimeter cube, in kilogram per meter cube that is 250, aluminum you see 2.7 and 2700, then iron 7.8 and 7800, like that. You just observe it. Each and every substances have its own densities. Another fact is the barometer. The barometer is used to measure the atmospheric pressure. To measure the atmospheric pressure, we are using the barometer. Makes use of mercury because of its high density. This barometer we are using the mercury, which is liquid metal. Why? Because of its high density. Now we are going to discuss about an important topic, speed. Okay students, it is time to wind up the class. The speed, the topic, the important topic speed we will discuss tomorrow's session. Now, thank you and have a nice day.